Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Mainuddin. I will present about introduction. This project is about designing and simulating a scalable distributed system. We focus on three main parts: process management, naming, and data replication. For process management, we use smart reading to show how different tasks can run at the same time. In naming, we try both flat and structured model like a DNS system to show how service can be found in a network. For data replication, we test two types of consistency: sequential consistency, where all updates happen in the same order, and eventual consistency, where update may be delayed but all nodes will catch up over time. The goal of the project is to apply what we learn about distributed system, understand the pros and cons of different methods, and test our design through simulation. And about the system design overview, this system uses virtual node called A, B, and C to create a distributed network. Each node runs several processes at the same time using multi-reading. These processes talk to each other by sending messages through simulate socket or share memory using tools like pattern reading queue. The system has two naming methods. The first is flat naming, which use simple key value pair like service 1 to IP port. The second is structured naming, which work like DNS and use names such as service1.dept, department.university.edu. There are three ways the system keeps data consistent. Sequential consistency makes sure all updates happen in the same order. Eventual consistency lets update happen at different time but a node will match in the end. Client-centric consistency let each client keep track of the latest data version it has seen. The design shows how to build a distributed system that is easy to scale and reliable.
For simulation demo, this is the coding. Okay, and this is the main. Okay, now for the output. First, we put the input first on node A, and then we get the node B, and then we print the node C, get the node C, print node B, and last but not least, exit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Safahan bin Muhammad Yusof, metric number 076587. So today I would like to talk about trade of analysis. So we have two parts: design comparison, tools and materials. So for design comparison, the naming system means data can be looked up quickly and easily. While structured means the data is organized in a way that makes it grow and become scalable over time. For process model, for trace memory is shared between them by the processes. Each one is isolated from the others. For consistency models, when the functions are applied one after another, it's called sequential, strong, less scalable. In the end, high availability, look less, and maintaining strong consistency. Next, tools and material, language and libraries. Python often trading time and look for multi-threaded tasks. For tools, diagrams are made with Draw.io and GitHub is used for version control. Google Docs is used for collaboration, and VS Code is development tools.
Thank you to the last presenter. Now I'll be presenting the lessons we have learned from the system. So in terms of system design, it is a modular and well-structured architecture that would help us in the simulation. Other than that, for the threat management, the concurrency control is crucial as it takes a part in locks and synchronization. Now, for the naming, we have used a flat naming because it is easier to simulate. Meanwhile, for the structured naming offers a better scalability. For consistency, it's not one size fits all, so the model choice would depend on the use case that we are testing. And now, for the recommendations and further future improvements. Our team would implement a real network-based communication, for example, sockets. Other than that, we would also simulate the failures and recovery to increase our fault tolerance. The team would also like to add a DHT-based structured naming, e.g. chords, so it would have a better scalability for bigger projects. A graph-based metric collection would also help for the system because of its latency and update lag. And lastly, we would make a better UI visualization so users can have a better experience.
Assalamualaikum warahmatullahi wabarakatuh. This is our group role contribution slide with the name and our respective role, and most important, what is our main task is shown in this table. For example, my name is Syed Asfar. My role is process and thread model developer, and my main task is build process simulation using threads. In conclusion, lesson learned is data sync across nodes is complex and structure naming scales better. For recommendation, I use modular architecture and visualize system design, and also for future improvement, add process migration and implement DHT based naming.